This content features my AI-generated voice and an AI avatar. The content, opinions, and professional assessments are entirely my own and are based on my original materials. Using advanced technology allows me to bring you new content more quickly, more consistently, and even more up-to-date insights. Now enjoy watching and listening.
In a traditional orthodontic lab, production inevitably stops the moment your staff turns off the lights and heads home for the evening. This creates a hard ceiling on your practice's capacity, a bottleneck that forces you to wait for the morning rush to start pouring stone and prepping models. But in a lean thinking practice, the end of the clinical day is merely the transition to the next production cycle. We have to shift our mindset to see the office not just as a treatment facility, but as a high-output manufacturing hub that continues to generate value while the rest of the world is asleep. This digital night shift is one of the most significant advantages of modern orthodontics, yet many practitioners fail to treat it with the industrial-level rigor it requires. When your digital workflow operates on a 24-hour clock, a 3D printer can process an entire afternoon's worth of intraoral scans while the office is empty, delivering a full bank of precise models by the time your team arrives the next morning. This allows your staff to start their day with a lab that is already stocked, moving immediately into appliance fabrication without the messy, time-consuming rush of analog stonework. However, achieving operational excellence in this area means recognizing that these machines are industrial-grade engines, not just high-tech toys. Running a digital lab unattended overnight requires a leadership mindset focused on proactive risk management. For your practice to truly run on autopilot, you must implement a robust safety infrastructure. Consider the simple power of remote webcam monitoring and smart plug emergency shutoff systems accessible via smartphone. These aren't just gadgets, they are the protocols that ensure a minor printing failure at 2 a.m., like a filament jam or a build plate detachment, doesn't escalate into a significant liability or a wasted day of production. Establishing these fail-safes is what separates a chaotic, stressful digital transition from a controlled, scalable system that actually supports your growth. As clinic owners, we have to move away from the hope it works mentality and toward a state of total operational oversight. To maximize this efficiency, we also have to make a strategic choice between the two primary workhorses of the digital lab: filament-based FDM printers and light-cured resin systems. In the world of lean management, we value simplicity and health. Filament systems using PLA are essentially high-precision spiders spinning webs from cornstarch-based materials. They are non-toxic, require minimal ventilation, and produce very little hazardous waste, which aligns perfectly with modern health standards for both our staff and our patients. Resin systems, while offering a smoother surface finish, introduce a massive amount of what I call administrative ballast. They require heavy-duty ventilation for chemical fumes, flammable alcohol washes, and specialized UV curing stations. The hidden costs of speed in resin printing are often substantial and frequently overlooked by practitioners. While a resin printer might be faster at the actual printing stage, the labor-intensive nature of the cleanup often negates those gains. High-quality resins can be 4 times as expensive as filament, and the constant need to manage chemical waste and replace delicate film liners impacts your profit margins more than you might realize. In a lean practice, we look at the total touch time, the actual minutes a staff member spends handling the model from the moment it leaves the machine until it is ready for the patient. A filament model, when printed correctly, is often ready for vacuum forming almost immediately after it is removed from the build plate. There is no messy cleanup, no chemical baths, and no secondary curing process. Conversely, a resin model requires a multi-step journey of washing in isopropyl alcohol, drying, and an extra 20 minutes in a UV oven. When you calculate the aggregate labor costs and the overhead of managing hazardous materials, the fast resin option often becomes the more expensive and less efficient route for standard orthodontic models. Efficiency is not measured by the speed of the machine alone, but by the time and cost required to go from a digital scan to a finished appliance in the patient's hands. Implementing a 3D printing strategy is like maintaining a high-performance vehicle. It requires a team that is trained in basic troubleshooting so that when a machine inevitably stops, the clinical flow doesn't stall with it. Leadership must ensure that the digital lab is not a black box that only one person understands, but a transparent, reliable system that the entire clinical team can support. By balancing production costs, material safety, and dimensional accuracy, you build a resilient lab that serves as the primary engine of your practice's growth. This allows you to leave behind the dusty, labor-heavy world of plaster and move into a clean, precise, and highly profitable future where your practice is always productive, even when you aren't there. Thank you for your time, and I'll see you in the next video.